54, we have kind of a crossroads where we decide, all right, or am I going to make a substitution? Am I going to go directly for U substitution? But we always want to remember, like, what are the good friendly trig expressions? So secant squared is a good one. That's why it says on the previous page, can I save a secant squared? Can I save a secant tangent? Well, I have a secant squared right here. All right, the 3x might throw a wrinkle into this, but we know that the antiderivative of secant squared is tangent. So let's try letting u be equal to tangent, just tangent, of 3x, and see where that takes us. So du would be equal to secant squared, good first step, 3x, times the derivative on the inside, which is going to be a 3. So du dx, multiply both sides by a dx, and you get 3 secant squared 3x dx. Now I only need a secant squared 3x dx, so I don't want that 3 there. So I'm going to divide both sides by 3. So 1/3 du is going to be equal to secant squared 3x dx. So we're in good shape now because I can swap out the tangent 3x for a u, so that's u to the 4th. And in place of the secant squared 3x dx, I could put a 1/3 du. So increase the exponent by 1, divide by the new exponent, and you have an antiderivative in terms of u. Now I just have to swap back the tangent of 3x for the u, with that tangent being raised to the 5th power, and you have it. All right, so not too bad, but if you go down the wrong road, and for this problem I've definitely gone down the wrong road before, you can find yourself kind of spinning your wheels a little bit. However, once you identify that, sometimes the simplest solution is the way to go, it makes life a lot easier. All right. With cosecants and cotangents, ask yourself, can I save a cosecant squared? Right? Because the antiderivative of cosecant squared is cotangent, well, negative cotangent. Or a cosecant cotangent, because the antiderivative of cosecant cotangent is negative cosecant. All right, so I'm looking at this, asking myself, all right, well, what can I save? Well, I have a cosecant squared in there, right? Except it happens a couple of times, in the sense that this could be thought of as cosecant squared of x squared. All right, so that's something. All right, because the antiderivative of that would be cotangent. Well, negative cotangent. So let's try that. If I let u be equal to cotangent of x, du is going to be equal to negative cosecant squared x dx. All right. So looking at that, we kind of run into a little bit of a problem here, because that'll allow me to cancel one of those factors of cosine squared x, but not both of them. All right. So what we might want to do is a little bit of kind of a transformation, all right, and that is convert one of those cosecant squares over into something involving cotangent. All right, so I'm going to hold on to that work for a second. I'm going to write this as cosecant squared x times cosecant squared x times cotangent to the 4th of x dx. All right. Now, in terms of rules, it's on the previous page, so I'll just rewrite it here. If you have sine squared plus cosine squared equal to 1, and you divide everything by sine, we'd be looking at 1 plus cotangent squared A is equal to cosecant squared A. So that's the relation that we're working with here, which tells me that I can take one of these. I can do it for both, but it's going to best serve us to do it for only one of them, and make that a cotangent, or 1 plus cotangent squared. Everything else will remain the same. I did not give myself enough room there. I don't know what that is. That's part of the arrowhead, I guess. All right. And so now we're in a little bit better shape because I can still let my u be equal to cotangent of x. Every instance of a cotangent is going to get swapped out for a u. So all of these cotangents, so I got one of them here, and I got 4 of them there, power of 4. I want to get rid of the cosecant squared. Negative du is going to be equal to cosecant squared x dx. Green is what I want to go for here. So this can go away now. So I'd be looking at negative 1 plus u squared times u to the 4th du. Little distributive property. Negative u to the 4th minus u to the 6th du. Integrate. Negative 1/5 u to the 5th minus 1/7 u to the 7th plus c. Bringing the u back in. Negative 1/5 cotangent of x to the 5th power minus 1/7 cotangent to the 7th of x plus c. And there you go. All right, so it's kind of like you go down a road, make an adjustment if you can, or if you need to, and if not, then you got to try something else. All right, fortunately, we didn't have to try something else.